Hey guys, this is Shelby with the Rogers Public Library. This week's theme for Full Steam Ahead is electricity. So I have an experiment and a craft for you guys today. For the craft, we're going to be talking about what's called current electricity. And for the experiment, we're going to be talking about static electricity. So these are related. The first thing you need to know that electricity is a form of energy, just like heat or kinetic energy, which is what we use when we move our bodies. And electricity is caused by the movement of electrons. So what are electrons? So this is what an atom looks like. It's not a perfect model. There's actually some more particles in here, but the three that we need to worry about now are protons and neutrons, which are in the nucleus of the atom, and electrons, which orbit around the nucleus. Now, neutrons are electrically neutral. Protons, which are the purple ones, are electrically positive, and electrons are electrically negative. So just like magnets, positrons or protons attract negative electrons. And the electron that actually moves and causes electricity to happen is this one on the outside. It's called a valence electron or a free electron. In the case of this atom, which is this is what copper looks like. We're not using any copper right now, but that's what's in most of the wires that run through our houses, because it's very good at conducting electricity. So there's some complicated reasons why the valence electron of certain materials conducts electricity and others don't. It has to do with how many valence electrons it has. This one just has one. And a lot of things that conduct electricity that are called conductors only have one or two or three. And things that have more valence electrons are called insulators. So here for our craft, we have a conductor. This is aluminum foil. And we can use aluminum foil or something similar to create a circuit, right? So we have a battery. The electricity in our houses isn't produced by batteries. It's produced by something called electric induction. And a battery is created or uses chemical energy to create electricity. So there's some chemicals in here. They have fancy names. One of them is potassium hydroxide. That's what an ingredient in soap. There's also zinc and manganese dioxide. And these aren't really chemicals that you interact with a lot or that you want to. Potassium hydroxide in particular is really caustic, which means it can burn you. You don't want to cut it open and see what's inside. But they are a very good source of electricity actually. So when they interact, they make the electrons move over here to the negative terminal, right? And so they're all pulled up here, and as soon as they touch something else that conducts electricity, like for instance aluminum foil, they're going to want to flow out and around the aluminum foil and anything that we have on there and into the positive terminal, and then the whole process starts over again. So what we've done here is we have this little circuit that we made aluminum foil. I shaped it like a little star, and I have an LED. So an LED, it's just, there's some gas in there, and when it passes through, it makes it light up. And so you can create a little electrical artworks with the battery and LED, right? So now we have a shining star, or we would if I could get it to stay on it pretty well. Here we go, yeah. This is another thing that you can do involving LEDs. So I drew a little picture. It's a park bench and a light. You can use anything for your light source. I have another one here. We're not going to use this battery because it's a little too strong. Instead, we're going to use this one. It is a 3-volt battery. It's made out of lithium, so it works a little bit different from this one. But we're going to put it through. And now our little scene has a street lamp, right? So yeah, there's a lot of really interesting things that you can do with LEDs and batteries in artwork. And these are just the two I thought of. You might come up with some interesting ideas on your own. And so now for static electricity. So static electricity doesn't move. Static means it sits still. So there's electrons pooling up. So we're going to need a balloon for this. So electrons don't actually like to pool up, they like to move. And so because of this, static electricity usually happens with material that doesn't conduct electrons very well, like rubber. Rubber is an insulator. So sometimes when you rub two substances together, there's something called the triboelectric effect, and that just means electricity caused by friction. So I can rub the balloon over my head, and I can do this for a good while. This is called an electroscope. Watch the little foil on the inside. So it moved, right? And I can make it stop moving. So hair, you can also do this with something like wool or fur, if you have a dog or a cat or something like that and you want to rub a balloon on them. So what's happening is that I have a lot of electrons in my hair. And when I rub the balloon against my hair, the electrons from my hair go on the balloon, but the balloon doesn't give any electrons to me. So the balloon gets a negative charge and my body gets a positive charge. Right? So this has more electrons, so it's negative. I have more protons, so I'm positive. And we can put this down with the copper. Copper is a conductor, remember we talked about that. And the electrons travel down to the aluminum foil, and because they both have a negative charge, they repel each other. And we can make it stop when we just touch it, and the electrons want to move to your body because, just to balance things out. They're your electrons in the first place, so they're just flowing back to you. So let's talk about this. So this is, as I said, it is an electroscope. I'm going to do the experiment again because I didn't realize there's a gunk on one side of the bottle. Ta-da. So what's it made out of? It is a soda bottle is the main part. And then the other parts of it are a foam pool needle, some copper wire, and 2 pieces of aluminum foil that I hooked on the end onto a hook. So yeah, it's pretty easy to make. I used scissors to cut the bottle and the foam, and then I just curled the wire with some pliers. So yeah, it's pretty easy. You don't have to curl the wire like this. You can also put a ball of aluminum foil on the end if your wire is a little bit shorter than mine was. Yeah, so you can use this to test for static electricity with the balloon. You can also test static electricity from some other materials. So, like I said earlier, this is caused by triboelectricity. There's this thing called the triboelectric series, and it's you can take 2 things on this list, and the farther away from each other they are, the more static electricity you'll produce when you rub them together. So for instance, you could take a piece of glass and a piece of polyethylene, which is a type of plastic, and rub them together and get a lot of static electricity compared to us when we just rubbed hair against rubber, natural rubber, which is right here in the middle of the list. Yeah, so you can be a little scientist with this and try to figure out if you can replicate the results on the triboelectric series, which is actually from an experiment way back when in the 18th century. Yeah, so hopefully you guys learned something about electricity today. I'll see you guys next Thursday.